All right. Everyone having a good day? There we go, that's better. I just wanted to let you all know that it's really beautiful outside. Not to do anything. Hi, well thanks. Looks like we're going to get started. I don't have a lot of pictures of my cat yawning, but I do have a lot of pictures of her sticking her arms out as far as she can. We call her long arm of the claw. Because how many of you guys have cats? How many of you have a cute little name for your cat that you whisper in their ear? Admit it. Yeah, I do. We always call her long arm of the claw. That's Zach. Despite the name, it's a she, which is always fun when you take her to the vet and they go, "Oh, how's he doing?" And you're like, "It's a she." You always have to go through that mental thing of, do I bother mentioning it? But you always do because, you know, look at her. Okay, so today I wanted to talk about something that I've been thinking about a lot as I go around and work with people and I watch other people's presentations and deal with a topic that is near and dear to my heart because it's really one of the core things that I use in my testing strategy. And mocks are such an easy scapegoat. When you hear people give talks, there's always just like, mocks suck, or hey, mocks make your testing fragile and your code fragile. So I thought I would talk a little bit because I consider myself an effective developer. I've been doing TDD for quite a while in some form or another, and for the most part I've been what I consider a strict isolationist, in that I pretty much isolate the code under test from its dependencies. And so I thought I'd talk a little bit about how I use them and what I use them for, and some of the common problems that people have with them, some of the common complaints that people do. But I want to expand it a little bit, because when you talk about mocks have a pretty set definition. They're expectation-based, so you tend to say, hey, I'm going to build one of these things, and I'm going to expect this method to be called on it. And then afterwards, you verify whether or not that method was called on it with certain parameters. But there's a whole range of uses for these. There's a set use when you're saying, okay, I want to make sure that it interacts with another object that way. So, but I'd like to expand it to be not just yay mocks, but really about test doubles in general. Really about that, all of the things we do, stubbing, putting just general doubles in, mocks, things like that. I tend to be very lax in my terms and just pretty much call everything a double or a stub or something like that. So throughout the course of the talk, I may drop the word stub when I'm talking about a mock, or I may drop the word mock when I'm talking about a stub. And I'll ask your, not really forgiveness, but just bear with me and assume that I'm talking about some form of a test double. And the type of test double is really there encoded in the example, in the test that I write. And so I tend not to differentiate that much. It's one of the things that I really like about the RSpec doubling library, or the mocking library, is that pretty much everything is an alias for everything else when you come down with it. When you say mock something or stub something, they're actually aliases for the same method. And they're really just giving you a test double that you can use for its appropriate purpose, whatever you want it to be in your test. So I'm going to talk more just about test doubles, some of the things that I use them for, and ways to do it. I'm going to go into talk a little bit about design as well. Before I get into that, though, there was something that I really, really thought you wanted to see. It's another picture of Zach. Look at her. She tends to have that look a lot of just like, really? And I'm always taking pictures of her, so she gets that look of sort of quiet disdain. But anyways. So I wanted to start off by talking about good design. How many of you know what good design is? And be honest. If I asked you and we're sitting around, you'd say, I know what good design is. Anybody? Come on, good. Okay, a couple people would say that. I don't really like to talk about good design because I find that everybody has their own opinions about it. And there's a lot of different views on it, and there's a lot of different truths. So the discussion about what makes a good design is really important. But I tend to only really be willing to have it while drinking beer, or preferably scotch. Because it's a fun conversation, and it's a great conversation to hear what other people value. But instead of good design, I like to do, and instead talk about better design. Because better design, I think we can talk about. I think better design we can come up with a definition of. Or at least, we can come up with a definition that you have to accept while I'm up here on stage. And better design, my views on better design really stem from the fact that there's one constant, there's one thing that we truly know about software. There's one thing that we know about developing applications. And that's that it changes. As we're building it, as we're showing it to our clients, as we're showing it to the person who asked for it, they're going to say, oh, yeah, that's great, but I didn't think about this one thing. Or, now that I see it, I realize that I actually wanted something else. And anybody ever have that experience? Yeah, how many of you like when that happens? How many of you just sit there and grumble and bitch about it over with the rest of your teammates of like, how come they didn't know? How come they couldn't tell me that? Man, scope creep. Or man, why couldn't they say that first? Because I already built my system. And then in our next breath, we're like, can't do upfront design. Can't gather all the requirements up front. So we've got this like dissonance. One of my favorite terms, cognitive dissonance. It's one of my favorites because I use it all the time wrongly. But it's that idea of being able to hold two ideas in your head that are sort of in conflict. So we come up and we talk about how we want to build iterative designs and we want to build small things, show it, build the next thing, show it. But when our customer comes and makes a change, we start to grumble. I do, everybody does. And so knowing this, what I consider better design is entirely given by easier to change. And I'm not talking about building a system that is ultimately extensible. You can configure it with XML or YAML, because this is a Ruby conference. So not like, oh man, this thing can do everything if you just change this one parameter. I saw a Rails application one time that I went in and was working with a friend. It was a rescue project, as I think is eventually going to become synonymous with Rails app. And it was, he was like, hey, I'm not going to tell you anything about the people who wrote this. And I looked at it, and I was like, Java developers. And he was like, yeah. And, well, he didn't ask me how I knew because it was clear. But one of the sort of fundamental characteristics of a Java application is basically you build a framework that is XML configured. So pretty much every Java application eventually ends up being an XML configured framework. So of course, in Ruby and in Rails, we're better than XML. XML sucks. So instead, if you can see where this is going, it was a Rails application that was basically they had built a framework on top of Rails that was configured with YAML. So there were like a couple hundred YAML files that were all in. The guy's like threw up his arms and he's like, I don't even know where to start. And I was like, wow, I'm glad I'm only here for a day. So I'm not talking about that. But what I'm talking about is that ability to go in, have a design that is easy to change. It's easy when you have to change some aspect of it, a feature changes. You can come in and just go, hey, I can find where I want to make the change. I know how to make the change safely. I can do it in one place. And all of this comes in to that fundamental thing of removing duplication, naming things well, having a good test suite. So this is kind of what I want to lead back to with all of the examples. And so I'm going to start with this. How many of you write some form of automated testing? You're all Ruby-ish, so your hands should go up. How many of you consider yourself doing test-driven development? How many of you write your tests first? How many of you write them after? I write my tests after, sometimes. It's good. So I'm going to talk a little bit about this and its implications on design. I also want to talk about OO. What I do find over the last couple years, I've been doing a lot of thinking about OO and dealing with people and working with people. And I got to say, we suck at OO. We are really bad at OO. One of the things that I think with the sort of resurgence in functional programming and saying, oh, OO doesn't work anymore, is mostly because we don't do OO very well. And we don't really abide by some of the core things about it. And there's one really important thing. There's one thing that OO is primarily about. And it's about messages. It's about sending messages between things. I'm currently learning Erlang, because as near as I can tell, Erlang is one of the purest OO languages that we have out there. It's this beautiful language that distills everything down to messaging between processes. It's about interactions. It's about the way things talk to each other. It's about the way that one object talks to the other one. It's not about inheritance. It's not about encapsulation, although those are important things. Inheritance isn't, don't do it. But it's really about interactions. It's about how things work with each other. And it's about services. It's about building good layered systems that are decoupled, that do one and only one thing well. And last, it's about this. It's about roles. It's about what are you using the object for. It's not about the objects themselves. One of the fundamental problems, I think, came about when most of us, when we were brought up, we were taught, okay, write all your use cases. And then what do you do right after you write your use cases? You underline the nouns. And then you make all of these classes. And then you underline the verbs, and you try to shoehorn them onto classes. If you think about what we do as developers, we automate process. Pretty much everything we do is about automating a process. And yet we start off our application, we start off our design, not by the process, not by the acts or the verbs, but by the nouns. And that leads us into these really crazy designs. These designs where you're trying to figure out where this behavior lives, rather than figuring out what are the behaviors, what are the services, what are the interactions that I have, and then figuring out what sort of things could be named that would group them together. Test-driven development is a great way to sort of focus on the interactions, focus on the services that we do, the messages that we send. In Ruby, messages are sort of brought to life via effectively method calls, even though they do behave a lot like message passing. We do have things like method missing and the like. But I wanted to talk a little bit about TDD and its sister, test-first development. I have a very set definition for these two. They're not the same definition that a lot of people use, but I want to let you know, because if you hold by these, you can kind of differentiate and not get into that place where you're like, oh, yeah, I do TDD, and someone goes, no, you don't. And then you feel bad, and somebody's making you feel bad because you're not doing TDD, because if you don't do TDD, you're going to hell. So I want to talk about the difference between these two. And as we become developers, as we move on through our careers, we start writing automated tests, and we write them after, and then we start writing them while, and then we start writing them first, and then we start noticing the effects that the tests have on us. And the main difference between these two, the way that we listen to the effects, I like to say, is our reaction to pain. The primary difference in my definition, as I like to separate these out, is about reaction to pain. What do you do when you find it difficult to test? For test first, I like to say you change your tests. You might write helper methods. You might, God forbid, use something like factory girl, something that hides the complexity of your tests, something that says, oh, this is a pain to set up, so I'm going to make something that makes it not painful to set up that I can reuse in my tests. And that's okay. And it's a valuable thing, because while we're learning how to do this, we tend to start off focusing there on the tests. But test-driven, as you sort of move in and listen to your tests more, you start moving into this idea of test-driven development brings in this idea of when you find something difficult to test, change the design. Have that be your default behavior. Have that be your natural reaction to something that's difficult to test. And test doubles, they often highlight pain. Some of the complaints that people have about test doubles are painful things, fragility or coupling or all of this. And so rather than changing the tests, maybe not using test doubles, or maybe changing the way that we use them, why not take a look at what those are telling you about your design? Have your default be change the design so that it isn't a pain, so that it isn't a pain to test. Here's another picture of Zach, just to wake you guys up. Okay, so let's talk a couple examples, a couple common ones that people talk about. I run these workshops called Code Retreats. It's not important what they are. They're awesome. But what I'm doing is I'm building an application that shows which ones are running that day. They run on the weekends usually. There's generally a couple of them running on a Saturday somewhere around the world. So I'm writing this application that allows people to register an event, and it'll show it on the day, and they can do all of this cool manipulation. And my first pass at it looked like this. It's a fairly, what I consider, an idiomatic Rails way of doing it. Anybody else have code like this in their app? Well, for the most part. Anybody awake? Okay, good. One person. So, I'm looking at it. I have an index. I'm passing it over. I do a find on my model. I pass in the hash. What's it scheduled for? Is it running? And I write a test. Retrieves the running today. Create a stub. Should receive find. Schedule. There's my hash. This is a pain. And this is a very common one. Anybody else run into this and be like, man, this sucks? Okay, I'm going to always just stand here with my hand up until people raise their hand. Because this is a common complaint, and it's a valid complaint. When you change this hash, you have to change your tests. And that's painful. It's fragile. Feels very fragile. It feels almost like I'm duplicating the implementation here. It's pain. Now, what we might say is let's not use a test double. let's, for some reason, actually hit the database there, so that if we change the hash, we don't have to do it. But let's take that pain and just sort of think about it for a second. Why is this information relevant to the controller? Why does the controller know the fields on my model, how to set them, what type they are? It knows that running is a Boolean, knows that this is the way that you find it out. A controller's job, in my opinion, should be to take the parameters from the HTTP request, send it to something, and then figure out what to render based on the result of that. And when you do stuff like this, what you're doing is you're bypassing layers. You're letting the controller reach in. It's odd. You're letting these layers sort of mix in, the abstraction levels mix in together. You're letting the controller call the database. That seems like a strange thing for the controller to do. Is it fast because we have active record and I can hack out all of this stuff and yay, I can, write my blog in 10 minutes? True. But most of us work on applications that need to be maintained. Most of us work on applications where that hash is going to change. One of the things that we like to abide by, controllers should know what they want, not how they want it. They should come through, they should look at it and say, okay, well, my job is to figure out, based on the request, what I want. So it's better to insert a layer in between it. Some sort of set of services that you have, that the controller talks to those services that are named well, that talk about what it actually is. Anybody ever read this paper? No? Phenomenal paper. Guy named David Parnas. It's one of those papers that you read and then you go, did they really know everything back in the 70s? Or rather, what I like to look at it is, at what point did we lose all of this knowledge that was there? At what point did we get this cut where there was all of this thought, this important thought going on? And then suddenly we are all just like hacking away, arguing about whether or not you should write tests, or arguing or not whether you should build a class. And there's all of these fantastic papers out there from the 70s and the early 80s, and mid and early 90s, that really talk about research into these ideas. This guy, David Parnas, this is a paper about how do you decompose your system into modules, which is convenient since that's the title of it. And so, laugh. Wow, you guys are a tough crowd. So what they did was they actually ran a little bit of an experiment on a code base. They split it into modules that were more kind of like an object graph. So they were splitting it into modules that were more on the things it worked with, as opposed to what it was supposed to be doing. And then they went and they split the same system into a set of layers based on the services it provided. And sort of a layer cake design rather than sort of the object graph, whatever they call it, ravioli designs that they talk about. And what they found was that if you split your system into a more layer cake design, a set of services that are very low level, and then there's a slightly higher abstraction level above them, and then a slightly higher level abstraction above them, that the system naturally becomes more maintainable. You end up being able to swap out sections. You tend to be able to change it a lot more easily. And so we have things like scopes. So we have this extra thing. It's not a physical layer. It's much more of a logical layer between the controller and the underlying database itself. So we might write, and if you notice, the example became significantly more simple. So by looking at the pain of our tests and just saying, hey, we shouldn't be passing the hash in. We should be asking ourselves, what does that hash represent? And giving ourselves, in this case, a scope or a method. You don't know how I'm doing it. It's just something that says, hey, the index, the controller's job is simply to get the today's code retreats. So by listening to that pain point, rather than going, the test double sucks, because if I change the controller or the hash, I have to change the test, we actually let that influence our design. And so we focus then on the what. What is the index interested in, not the how of it? And our tests become quite a bit more clear. You can look at it, and an interesting thing, too, is notice that the name of my example is it retrieves retreats running today. And if you look at the code in the example, it pretty much directly reflects the textual description. The words kind of run. Maybe today's is a little weird. Maybe it could be running today, something like that. But there's this sort of synchronicity, the symmetry between the textual description and the stub that I return. And so it's always better to delegate the how down a ways and letting the fact that we're not running through all of the layers down to the database. We just set ourselves this nice double. We don't have to worry about anything about the how. Because in the end, TDD, it's about design. Test first is very much focused on verification. TDD, it's about the design, and this is the core way to take advantage of it, is about changing your design, not your tests. It's about focusing on the usage of something, not on how it's constructed. Here's another picture of Zach. Focusing on the usage of this box. OK, so I like presenters. And I like presenters, especially in the Rails community, because we argue about whether something is a presenter or not. So I like them. I always like arguing semantics of, like, is this really a presenter? And really what it is it's something that sort of provides me a better interface to the underlying data. Something that is focused on what the view needs. So I'm going to call it a presenter, and as I do with a lot of things, I'm just going to go willy-nilly with vocabulary, and if it's wrong, please bear with me. So come here, and I look at a test for this. So it's reasonable. I wrap the today's code retreats in this code retreats presenter. It's going to have some things that the view uses. And if I look at the test, I set up a stub for today's code retreats. Code retreats should receive today. Oh, I have this cool thing here. Today's code retreats. Create a presenter that's a stub. I stub out the for method. I pass this stub into that one. And I get this stub back. And then I make sure it gets assigned. Anybody write tests like this? Ever? OK, there's a few more people. I'm just going to stand here. Now, here's a weirdness. Whoa, craziness. One of the kind of fundamental rules is that test doubles should not return test doubles. It's sort of building you into this weird kind of interdependency between them. If you start to, there's how many different ways here could this test have to change? We've got if this thing changes or that thing changes or what comes back or anything like that. It's all kind of weird. So ugh. This is not something. This is a pain point in our tests. There's too much detail. I know that I'm getting a code retreat presenter. I'm passing in today's. It feels like I'm bouncing between layers of abstraction. I'm bouncing between the layer that is saying, these are the code retreats I want to use, and then this layer of what I send out to the view. So rather than jumping through and saying, OK, well, I'm just going to write some helpers that will let me set up a double that returns a double, we can look at what the design is. And as I tend to do, I always want to start with my example. I want to start and say, what would make this example look better? What would make this example more maintainable, more clear? Because this is not really that clear. It's kind of long. I'm not 100% sure what it's supposed to be doing. So we can simplify it. We can simplify it so that we just ask the presenter for today's. Now here's where we may get into arguments, oh, is that the presenter's role? Well, you know, maybe I'm not completely adamant that these are presenters or not, or the term's right. So we simplify the example by just saying, when I ask this guy for today's, I get back to presenter. It takes us back to what we had originally, where we were saying coderetrieve.today's. Now, by focusing on making the example simpler, we then notice that the code becomes simpler. The code stops having this sort of small abstraction jumping. It's focused back on what the controller needs to know, which is what I'm looking for is today's code retreats. I'm not sure why this was left blank, but I'm sure it was intentional. And TDD, when you come into it, it has this sense of refactoring. Once we've abstracted ourselves out, we allow ourselves to really start to think about the APIs, think about the service names, think about what makes it difficult, where are the coupling points. Think about where are the discomforts in these tests? Where are the parts of the system that I can move away from? I don't have to have these, my entire system loaded. I don't have to have all of the pieces interacting in order to do the refactorings. And instead, we can really focus on just that one small part of the design. As you could see, you can look and see in our examples some of the things that cause pain, that highlight the pain. And when we go through the refactoring phases, there's basically 4 rules. Has anybody heard of these before? The 4 rules of simple design? Look at that, a couple people. So the 4 rules of simple design were codified by Kent Beck in the late 90s. Kent Beck is generally considered the father of test-driven development. He's one of the sort of key people back in the extreme programming days. And he codified these based on a lot of what he had looked at of what are the core things about design? What are the core things that we should be focused on when we are building our systems? We talk and we love to talk about the solid principles. We love design patterns. We love all of these higher level things that are just like, oh, that's going to make my design awesome. But if you boil it down and if you get down to the very core of it, it's really these 4 rules. The very first one is test pass. And it basically says, if you can't verify that your system works, it doesn't matter how good your design is. You could have the greatest design ever, but if you can't verify how it works, it doesn't do you any good. In our sort of modern age, we consider most of these automated, because if you have a 2-week QA cycle or a 1-month QA cycle, anybody ever worked at a place where you had like a 2-week or a 1-month QA cycle and you'd put your code out there and then you'd wait a month and then, in a couple days bugs would start coming back and you're like, what was that? What was I doing there? I don't remember. As opposed to what most of us are used to now, which is click a button, show the stuff that you screwed up. Number 2 is reveals intent. It's really about naming. And this is one of those places where being able to isolate yourself from the rest of the system, being able to look at your system as a series of layers that you can stub, really comes into practice. And you get a lot of benefit from that because you can start to think about the names that you use at that level without having to worry, care, or even know about the implementation underneath it. So you can focus instead on what these names of these services are. the things that your doubles are exposing. And the third one is no duplication. How many people have read Pragmatic Programmer? Awesome. Excellent. If you haven't, you should. You can now get it from the Pragmatic Press, DRM free, yay, all of that. Great book. In it, they coined this term dry. Everybody knows dry? Don't repeat yourself. And it's interesting because if you look at what it talks about, is it doesn't actually have anything to do with code. A lot of people say, you know, if you write it twice, you should extract it. And some people might have a 3-strike rule that, oh, if I write it 3 times, then I'm going to extract it, because then I'm going to have a sense of it. But what the dry principle really is about, what it states, is that every piece of knowledge in your system should have one and only one representation. And when you look at duplication as knowledge duplication, it really changes the way you look at your design. And by isolating yourself from a lot of the rest of the system, you can highlight knowledge centers. You can highlight those places that capture information in your system. And the fourth one is small. Once you've expanded it by writing more code, eliminating duplication, you can look to see if there's any parts that can be collapsed. So these really are the core. And when you're refactoring, when you're writing these tests and isolating yourself from the rest of your system, these are what you focus on. Okay. So I have a take-home challenge for you. It's an interesting one because it's something that a lot of us face. So here's my code retreat. I have, outer accessible. I have some validations that these have to be there. You have to have a location, a facilitator, and a host. There's my scope. And down here, I'm writing this. When I test scopes, I always hit the database. It's the only time that I actually hit the database. But if I'm testing something that's generating SQL for me, it probably makes sense to hit the database, make sure that the SQL is right. So you come in and you create one for today, you create one for yesterday, you create one for tomorrow, and what you ask, it should just have today's event. But this has a lot of coupling in it. The fact that I have to put this facilitator and the host in my test, all I'm really caring about is the date. This is unnecessary noise, but I can't do anything with it. I have to have it there. And it gives me false positives, this style of test. If yesterday's or tomorrow's are not created in the database, so if it fails because of the validation, it's not going to care. If it doesn't create tomorrow, so I can't take those out. This is a testing pain. This is a concrete pain that we have here that I'm trying to test, that it looks at the scheduled for, but I have to have this extra information. So the take-home challenge that I would give you, because everybody likes challenges, and why not give you something to code on, is really to think about this. This is a fundamental pain in a lot of testing. So how can you change the design to fix this? What can you do to this so that you can actually test this stuff without this unnecessary noise? So there's your take-home challenge. That was it. Thank you. There's a picture of me with my cat. It looks like I have 7 minutes. If anybody has any questions. Oh, yes. Yes. I'll put it at the end of the slides, and then I'll put the slides up there. Yeah, I think that whole app is up there. So, any other questions? No? Was that 2 questions? Holding, presenting questions? No? Awesome. Well, have the rest of the day. What? Aaron? No, it is Comic Sans. That's the bit.ly name. It's actually a link to the McSweeney's article. That's so it's well worth reading. Comic Sans is the ultimate presentation font. Any other questions? Yes. Oh, hey. Okay, there we go. Any other questions or random things you would like me to do? I'm actually learning how to do the Running Man, but I'm not ready yet. Probably Australia, I think I'm going to do. I'm going to try to get Aaron to dance with me. Yes, there's first in the red shirt. Mm-hmm. That wouldn't be much of a challenge if I didn't. So the challenge here is, this is something that I find annoying, is that this validations here tightly couples all of the rest of your code to this. So it's an interesting design challenge of what would you do? How would you change the way that this works? How maybe you would change the way that you do validations. It's arguable that this is not optimal for building something decoupled. It's arguable. It's a trade-off between speed and, speed of development, and I don't even know if that's a trade-off. But it's an interesting one because it's so fundamental to Rails to have these validations. Yes? Mm-hmm. Mm-hmm. So the fact that we have these, like now there's a layer, this presenter layer, and then there's this logical layer of scopes, and then down. So what you're saying is that the pain that you felt when you do this is that you have to keep all of the layers in your head at one time. My response would be, why do you have to keep all those layers in your head at one time? Mm-hmm. Mm-hmm. I guess a lot of it comes down to what value do you get out of that? What's the pain that you're trying to do? Is the integration test making sure that you've actually implemented all of them? Mm-hmm. Mm-hmm. So one of the things, by chance, so it's one of the common things that, if I change this one, then this guy doesn't have to change. Do you, by chance, do where you kind of build a whole layer and then build the layer underneath it that it's calling? Okay. So try instead doing straight through, like a vertical slice through your thing. Do you often run into where you change something lower and you hit up top? No. It's actually a common. It's one of the most common fears. I was just talking to a guy Friday about it. A guy who named Josh Cheek, who writes a system called Surrogate. And it's a test doubling system that'll actually make sure that it reflects the thing it's doubling. So if you change a thing there, it does that. I so rarely run into that problem where I change something underneath and the thing above it, like mismatches, that it's usually, I'm not sure why. Like, I don't know if that's something that people run into a lot, because I don't tend to. It's a fear. And generally I tell people, is it a fear or is it something that you do a lot of times? And this is a lot when I do of other things as well, is we have these fears about changing and, whoa, what happens if I change something underneath? And then it blows up in production because the API mismatch. I guess a lot of it boils down to is that just doesn't happen to me that often. And I don't have that fear for some reason. Once or twice, but the added complexity of not doing that, or the added complexity of having something that matches that up, in my experience, doesn't pay off. But as with everything, your mileage may vary. But check out Surrogate, because it's specifically built to sort of counter that fear. So, good. Well, with 15 seconds left, that's it. Thank you very much. And we'll